Recording started.
Nat, thank you for allowing me to do that. I'm going to be recording this for people who are unable to be here this evening. There are two ways that you can ask me a question. There is a Q&A button and a chat button. So feel free to type in the Q&A button or in the Q&A section or the chat section and to me, and I will check that periodically as we go throughout the session tonight about geometry. So that's how you can communicate to me any questions along the way. I'd like to start off by thanking God for this time. So, Heavenly Father, I thank you for this opportunity for us to learn more about geometry. I pray you bless this time that we have together in Jesus' name. Amen. Okay, so tonight what we're going to be looking at, some objectives of what we're going to be covering. First of all, I want to make sure that everyone can see what I have here, the list of objectives, and along with can you hear me? So if anyone can type in the chat box, if you can see the list of objectives and if you can hear me, that would be great so that I can know for sure we're all good to go before we go any further. Just going to check that. There's the list of objectives. You see here. Let me fix that. I think you guys weren't able to see my screen. There we go. Now you should be able to see my objectives listed there. We're going to be using angle relationships to find measures of angles. We're also going to be using the Pythagorean Theorem to find the length of a side of a right triangle. We're also going to use perimeter and area to solve some application problems and use similar triangles on the length of a side that we don't know. So we can use a similar triangle relationship as well. So let's get started. First of all, we have this situation with two lines intersecting. Now, when two lines are intersecting, it is you have four angles formed, and there's two angles that are across from each other. Those two angles are across from each other. Sorry, I just wrote right on top of what's noted there. Okay, two angles right across from each other. And anytime you have intersecting lines, the angles across from each other have a special name. They're called vertical angles. And vertical angles. There's actually two pairs of vertical angles in the picture because there's the ones I have marked in black and then there's other ones marked in orange. Those are also vertical angles. So anytime you have two intersecting lines, there's two pairs of vertical angles formed. And the interesting thing about the vertical angles is that they are the same measure. So in order to find the values of like the measures of the angles, we need to find x. We know that. But in order to find x, I need to have some sort of relationship that I'm using to find x. So I'm going to use the vertical angle relationship to write an equation where those angles are equal to each other. So I have the 10x plus 15 equals 12x minus 3. That's how I come up with that equation. Without the equation, it's really hard for us to solve this problem, okay? We need to write that equation in order to figure out x, okay? So I noticed in my equation I have some x terms and I have some number terms, and our goal is to get all of the x terms on one side and all of the number terms on the other side. So I decided to move the x terms on the right side and the number terms on the left side, but it doesn't really matter which way you do that. I'm going to go ahead and add 3 to both sides, so that gives me 18 on the left, and then if I subtract 10x from both sides, that gives me a 2x on the right, and then I divide both sides by 2 to get x is 9. Now, I need to be careful because at this point, might be easy to just circle x is 9 and say we're done. But when we go back to the original question, we see that they're asking for the measures of the two angles, not for x. We need to find x so that we can find the measures of the angles. So once we have x, we can answer the question that they're asking. Okay, the answer is not 9 because the question is asking for the measures of the angles. So we're going to put 9 in for x, and for one of the angles, 10x plus 15, gives us 105 degrees. And since both angles are the same, that's the answer for both. So we have found the measures of the two angles that are marked here by substituting 9 in for x. We found that they're both 105 degrees. So that's using the vertical angle relationship, that the angles across from each other are going to be the same. And just for me to mention again, these angles in orange here are also equal to each other. The angles in orange that I marked are also equal to each other. So anytime you have intersecting lines, you have this vertical angle relationship. Okay, so next we're going to look at a different relationship between angles. Let's say we have this situation where lines L and M are parallel to each other. And then we have this other line N that is crossing over both of those parallel lines. We actually then have 8 angles formed because we have 2 pairs of intersecting lines. But since lines L and M are parallel to each other, it creates a whole other unique situation. So let's use our vertical angle scenario to help us out here. I know that if I look at how line L is intersecting with N, I see angles 2 and 3 are vertical angles, so I know those are equal to each other. And then I also see angles 4 and 1, also vertical angles, so I can see those are equal to each other. Now let's say I know that angle 2 is 100 degrees. Let's say I'm told that angle 2 is 100 degrees. So then I know angle 3 is also 100 degrees because they're going to be the same. Let's look at how we can find angles 1 and 4 from this relationship that we know. If I add the measures of angles 1, 2, 3, and 4, I am going to get 360 degrees total because it's going all the way around. Angles 2 and 3, that's 100 each, so that's 200 degrees. But I have 360 degrees when I go all the way around. So if I take 360 and take 200 away, that gives me 160. So I know what I have left to be divided up between angles 1 and 4 would be 160 degrees. And since angles 1 and 4 have to be the same, that means they're each 80. So this is 80 and this is 80. And you can always check your work by adding up all 4 angles and make sure you get 360 degrees total going all the way around the circle. Okay, so that's using the vertical angle relationship to find half of the angles we're supposed to find here. Now, let's move down to lines M and N intersecting. That's angles 5, 6, 7, and 8. When you have this unique situation with the lines being parallel, then what happens is this up here with the 80, 100, 80, 100 gets copied right there. It's exactly the same situation. Because the lines are parallel and they're intersecting the same line N, angles 5, 6, 7, and 8 are a copy of angles 1, 2, 3, and 4. So knowing that, since I know 5, 6, 7, and 8 is a copy of 1, 2, 3, and 4, I need to make some space here so I can write on it. I know that angle 6 would be 100 degrees. And angle 7 would be 100 degrees. And angle 8 would be 80 degrees, and angle 5 would be 80 degrees. So if I just know one angle out of 8 when I have the situation where the 2 lines are parallel and this other line intersecting it. If I only know one of the 8 angles, I can find the other 7 because I can use the vertical angle relationship to help me out. I can also use the fact that all 4 angles added together should give me 360 degrees total. And then the fact that L and M are parallel means I have an exact copy. So if you notice, we actually have the 80-degree angles are all equal to each other. The 100-degree angles are all equal to each other. Okay, so what happens is that angle 2, angle 3, angle 6, and angle 7 are 4 angles that are exactly the same measure. And also then angles 1, 4, 5, and 8 are the other 4 angles that are exactly the same measure. So let's say I know angle 5, and the question is asking me to find angle 4. I can look at this picture and go, oh, those are equal to each other. Because L and M are parallel, I can say those are equal. So this is a handy picture to have when you're working problems that involve parallel lines. So you might want to, have a sketch of this and mark the ones that are equal to each other so that when you're working homework problems that involve that situation, you have a reference to take a look at, okay? Now, you don't need to visually copy down everything that I'm saying and everything that I'm writing necessarily because if you want me to email you my slides, all you have to do is send me an email. And at the end of the presentation, I have my email address. You can just send me an email, and I'll email you my slides. So you don't have to try to write absolutely everything down that I'm saying. Okay, but this is a really good picture, and we're going to refer to this when we're doing the next problem. Okay, so here's the situation, and we have lines L and M parallel to each other, and we're supposed to find the measures of the angles. Now, the angles that are marked, that's a 2x minus 5, and that's an x plus 22. And if we refer back to the other picture, we can see that those would be angles that are equal to each other. The line that is intersecting lines L and M, this line right here, is slanted slightly different than the other line, but that doesn't matter. It's still, you have 2 parallel lines intersecting a third line. So it's the same situation. We can say that these angles are the same. In fact, I could even mark the other angles. All 4 of those angles are the same. Okay, but we don't have to find all 4. They're just asking us to find the 2 that have the markings on them with the 2x minus 5 and the x plus 22. So because they're equal to each other, and in order to find the measures of those angles, I need to find x. So just like in the last problem, when we need to find x, we write an equation, solve the equation to get x so that we can answer the question about the angles. So I know these are equal, so I can write an equation setting them equal to each other, and this time I moved x over to the left, so that's gone, and then I moved the numbers over to the right, so I added 5 to both sides, and I ended up with x equals 27. Just like I said previously, when you get x by itself, you don't just say 27 and move on, because 27 is just the number that we are going to put in for x into here to find out the angle measures. Now, we only really need to do one of the 2 because the angle measures are the same. So I'm going to put 27 in for x and for the one that says 2x minus 5, and that gives me 49 degrees. So since both angles are the same, I don't need to do that twice. I just know that's the answer, that both angles are 49 degrees. Okay, so let's take a look at another example. Looks like that. Lines L and M are parallel again. Now this one looks a little bit different only because we have 2 lines intersecting the parallel lines, okay? But we're only really going to look at one at a time. And so we have to pick a place to start. find the measures of angle 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to find the measures of, and 10. There's a 10. There should be a 10 right here. This is actually a 10 right there. Okay, so we're supposed to find the measures of angles 1 through 10, and I'm only given 2 of the angles, 120 degrees and 55 degrees. So where do we start in this picture? We start with angle measures that we know, and just go one at a time to see what we can find. Now, right away, I see some vertical angles. For instance, if I look at the 120 degree angle, I see that it's a vertical angle with angle 8, which tells me then angle 8 is 120 degrees. And then I can also find angles 9 and 10, because remember that all 4 of those angles have to add up to 360 degrees. And 120 degrees and 120 degrees, that's 240 degrees. So when I take 360 minus 240, 240 for the 2 angles that I know, that gives me 120. Now 120 degrees has to be divided up evenly between angles 9 and 10, because 9 and 10 are also vertical angles. They need to be the same. So that tells me angle 9 needs to be 60 degrees, and angle 10, 60 degrees. Okay, so I've already answered 3 of the questions. They want us to find angles 1 through 10. I have found 9, 8, 9, and 10. So we're getting somewhere, okay? Now, we need to worry about 7 and 6 later, because I don't have a way to have a relationship between this 4 set of angles and angles 7 and 6. I don't really have a connection there. What I do have, though, are parallel lines. So I can move up to this area. Knowing the fact that L and M are parallel to each other, I can use my parallel line scenario. Now, temporarily, I'm going to ignore the line that intersects with angles 7 and 6, and I'm just going to take a look at this line intersecting lines L and M. Sometimes if you have a problem like this, it's better just to redraw it without the line you're not looking at. Like this other line right here, I'm not going to look at that right now, and so it might be better to just, on your piece of paper, draw a line L, draw a line M, draw the line I have in green, and just work with it that way for a little bit so this other line just doesn't get in the way, okay? Now, we can use the fact that we have vertical angles to help us out, and also the fact that the lines are parallel. So vertical angles, I know right off the bat, I have vertical angles right there with the 55 and the 1, and I know that I said to ignore this for a moment, but I'm not going to ignore the parallel line and the vertical angles, though. So I'm going to go ahead and mark this as 55 degrees. Now let's take a look at our 2 parallel lines. I'm going to kind of highlight them in green here, and the line that's intersecting them. Remember that reference picture I told you to, we're going to keep going back to, which is right here, okay? So I can mark, using this as a reference, I can go ahead and mark which angles are the same in the picture for what we're working on. So I can go ahead and mark that this angle is the same as this angle is the same as this angle is the same as this angle. Those angles are all the same, which means they're all 120 degrees. Now, that tells me that angle 4 plus the 55 degrees is going to give me 120 degrees, angle 4. If you notice, angle 4 and that 55 degree angle adds up to 120, and the same thing over here because it's vertical angles with it, and I'm getting the 120 from here because line L and M are parallel, those angles are the same. So that tells me that angle 4 is 65 degrees. So, which also means angle 2 is 65 degrees. That's 65, that's 65. Oops, not 650. Okay, so we have angle 1 is 55, angle 2 is 65, angle 4 is 65. So we're getting somewhere with that. What we have left, angles 3 and 5. Notice that angles 3 and 5 are vertical angles, and that also would be the same as 9 and 1. Referring back to our picture of the two parallel lines and the third line, marking which angles are the same. So that tells me angle 3 has to be 60 degrees, and angle 5 also has to be 60 degrees. Okay, so we're getting somewhere. We're doing this piece at a time, looking for vertical angles and using the relationships of the parallel lines. All we have left are angles 6 and 7. Okay, so I kind of wrote all over everything. I need to clear my screen. All we have left, though, are angles 6 and 7. So we're going to take a look at these two lines and this line that intersects lines L and M. Kind of ignore the other line here for a minute. We know angle 1. We already found angle 1. Angle 1 was 55 degrees. Angle 1, 55 degrees. And using the parallel line relationship, I also see that 6 and 7 have to be the same as angle 1 and the 55 degrees. So these are each 55 degrees. Because I'm using lines L and M are parallel, and I'm using this blue third line that's intersecting them. So what makes this problem particularly confusing is the fact that you not only have the parallel lines, but you have two different lines intersecting the parallel lines. But notice what I did is that for a lot of this problem, I ignored one of the lines. So I started off with looking at the parallel lines with that line intersecting them and worked with it that way. And then I looked at the parallel lines with this other line intersecting them and looked at it that way. So you can't, it does get confusing if you try to look at it with all the lines all at once. And another thing I did is I started in the problem with what I knew. I didn't start finding angles 6 and 7 because if you look in the vicinity of angles 6 and 7 here, I don't know anything. I have nothing marked. I have no angle measures marked. So that is not where I want to start. I want to start in this picture where I have things that I know, like this 120 degrees, that I know. That's a good place to start because right away I can find angle 8, which helps me find angle 10, that's a 10, angle 10, and angle 9. So I'm able to find 3 angles right off the bat just by looking at where I have information. Also, this 55 degrees, I can find angle 1 right away by looking at that vertical angle. So I was able to find 3 or 4 angles right away just by starting at where I know information. And then from there, using this line intersecting the parallel lines to look for relationships, going back to that special situation of parallel lines intersecting a third line. And then after I found all those other angles, then I looked at angles 6 and 7 because I was able to then refer to this line intersecting the parallel lines, and that helped me with angles 6 and 7. Okay, so when you have, I hope that gives you some helpful hints on how to handle a homework problem that looks like that. It can look confusing, but you just have to take it in pieces and start with what you know. Okay, I'm checking the chat box and I don't see any questions, so I'm going to keep going. Okay, in this picture we have a triangle, and sorry, part of my triangle got cut off here, but it is a triangle, and we're going to use the relationship that the sums of the angles of a triangle is 180 degrees total. That's for any triangle, no matter the size. If it's a really small triangle or a really large triangle, anytime you add the three angles together, your total is going to be 180 degrees. So in order to find each angle, I need to find x. And in order to find x, I need to write an equation to solve for x. So we can use the fact that the sum is 180 degrees to write an equation to find x, and then once I know x, I put that number in to the expressions in the triangle to find the angle measures. So here's my equation. This is 3x minus 40, that's one of the angles. 1/2 x plus 130, another one of the angles, and then 3/2 x minus 10 is the third angle. So I took all three angles and I added them together and set it equal to 180. That gives me an equation, okay? And then a trick to get rid of fractions when you have an equation to solve is to multiply by the least common denominator, and the denominators here are all 2. So I'm going to multiply everything by 2, and that'll get rid of my fractions just because I'd rather not solve an equation with fractions. The key is, though, you have to multiply everything by 2. So the 3x turns to a 6x, the minus 40 turns to a minus 80, 1/2 times 2 is just 1, 130 times 2 is 260. Even the 180 on the right-hand side, I multiply times 2. And as long as you multiply the whole equation by 2, then you're good. And now I don't have any fractions. Okay, so now on the left side of the equal sign, I have all these terms, and you're going to combine like terms by putting the x ones together. I have 6x, a 1x, and a 3x. That gives me 10x. And then I have a negative 80 plus 260 minus 20 gives me a 160. Then subtract 160 from both sides, so 10x equals 200, so x is 20. So knowing that x is 20, then I can put that number into each of these expressions to find each angle measure. So we found that x is 20, so I'm going to put 20 in for this x, 20 in for this x, and 20 in for this x, and we'll be able to find all three angle measures. Okay, so 3 times 20 minus 40, that gives me 20 degrees. 1/2 times 20 plus 130 gives me 140 degrees. And then 3/2 times 20 minus 10 gives me 20 degrees. So when you, so we end up with the triangle where you have 140 degrees and then 2 angles that are 20 degrees. And it's a good idea to check this and make sure that when you add all 3 angles together that you get 180 degrees total, because otherwise, you know, you mess up somewhere along the way. So this is 3 times 20 minus 40, 1/2 times 20 plus 130, and then 3/2 times 20 minus 10. And that's how I ended up with the 3 angle measures for the triangle. Let's take a look at another example with triangles. Another angle relationship we have with triangles is that the measure of an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. So an exterior angle is basically where you take a side of a triangle and just extend it. And when you extend it out, an angle's formed. And so that's called the exterior angle because it's on the outside of the triangle. And then the angles on the inside of the triangle are called interior angles. And remote interior angles means the angles on the other side of the triangle. You see the ones that are marked here are not next to the 26x degrees. They're on the other side of the triangle. So the relationship we have here is that when you add those 2 interior angles together, it's going to equal 26x degrees. So that's what we're going to use to write our equation. And after we write our equation, we'll need to solve for x. And when we get our answer for x, we're going to put it back into these expressions to find the measures of each angle. Okay? So again, when you solve for x, you're not done. You have to take your answer for x and put it into each of these expressions to find each angle measure. Okay, so I add the 10x plus 15 plus 13x. That's the two interior angles, because you have the 10x plus 15 is one of them, 13x is the other one, and then it equals the exterior angle of 26x. And on the left-hand side, I have a 10x and a 13x, and I could add together and get 23x. And then I decided to move the x terms to the right, so I'm going to subtract 23x from both sides, which gives me 15 equals 3x, so x is 5. So again, I found that x is 5, so I go back to my triangle, and everywhere there's an x, I put a 5 to find the angle measures. And this is interior, this is interior. So you end up with two 65-degree angles. They just happen to be equal to each other in this example. They're not always going to be equal to each other. But you have two 65-degree angles. And then the exterior angle is 130 degrees. Now, just to double check, we did things okay here. When you add the two interior angles, you do get the measure of the exterior angle on the other side. The exterior angle has to be on the other side of the triangle. So you have the interior angles over here, and then on the other side of the triangle, you extend the side, and that gives you the exterior angle. So it's this right here, okay? So we're using that angle relationship in the triangle to write your equation, solve your equation, get your answer for x, put x, that number 5 back into the situation to find the measure of each angle. Okay. And so we're going to shift a little bit here from looking at angles in a triangle to look at the sides. And the Pythagorean theorem helps us to work with the sides of a right triangle. Now, the Pythagorean theorem only works for right triangles. It doesn't work for obtuse triangles or acute triangles. A and B do not have to be the same. I know in this picture they kind of look the same, but they're not always going to be the same. A and B don't have to be the same. The hypotenuse is always across from. See, if you're standing at the 90-degree angle and you look across, that's the hypotenuse. So it's always across from the right angle, and it always happens to be the longest side as well. Okay? And the Pythagorean theorem says that if you take the legs and square them and add them together, it equals the hypotenuse squared. So what we can do when we're working with right triangles is that we can use this to be able to write an equation to solve. Sometimes we might need to solve for x, or solve for maybe x is one of the sides. But if it's a right triangle, we can use this equation to write out an equation in order to solve for the problem. Okay, so let's take a look at a problem that involves a right triangle. At a point, it's a word problem. We haven't done any word problems yet tonight. At a point on the ground, 30 feet from the base of a tree, the distance to the top of the tree is 2 feet more than twice the height of the tree. Find the height of the tree. Now, some people read that and just go into panic mode, but what I'd like to do is let you know that you are not expected to just read this problem and know the answer. There is no way we expect you to just read that and go, oh, the height of the tree is, and come up with an answer. You have to do some drawing pictures, writing equations. There's no way around it. Now, I didn't draw a pretty tree here, so I'm going to go ahead and put in a tree. There's the height of the tree. I don't know, here's the base of the tree is right here. Now, we normally have things growing, like buildings or plants growing at a right angle to the ground. So there's the right angle in order to say this is the right triangle. And they're telling us we don't know the tree. We're supposed to find the height of the tree. So we're having the height of the tree be x. And we're told that the point on the ground from the base of the tree is 30 feet away. And we're also told that the tree distance from that point on the ground to the top of the tree is 2 feet more than twice the height of the tree. So that's 2 plus 2x, that piece right there. If you don't draw a picture, you're going to have a really hard time with this question, okay? Especially when you're given practical situations. They may give you the height of a building or height of a person. It's really important that you draw a picture so that you can see the relationship of what's going on. And in this case, I can see it's the right triangle because things grow perpendicular to the ground. And so we have our right angle and we have our right triangle, and the thing we don't know is x. So we can use the Pythagorean theorem to write out an equation, solve for x. Now the good thing is, because we assigned the tree to be x, whenever we get our answer for x, that's what we want to know, because they want us to find the height of the tree, and the height of the tree is x. So once we solve for x, we're good for this particular problem. Okay, so we're going to use Pythagorean theorem to write an equation. So there's my leg of x, and my other leg of 30, and each of those being squared is equal to 2 plus 2x squared. That's the hypotenuse squared. Now, I want to warn you that 2 plus 2x squared is not 4 plus 4x squared. It is not, because 2 plus 2x squared is this expression, 2 plus 2x times 2 plus 2x, which you have to use FOIL to multiply, which gives you 4 plus 4x plus 4x plus 4x squared, which is 4 plus 8x plus 4x squared. You see, that's not the same thing. So please be careful. It's a really common mistake to write that which is not correct. So I'm going to go ahead and erase it because I hate writing things that are wrong. I hope that people don't see that and go, oh yeah, and then copy it down. So just something that can help you as you're doing this, which I always do. If I see parentheses squared, I just go ahead and write it without parentheses. So I write it twice. And that is a good visual reminder that you can't just say that that's 4 plus 4x squared, okay? So after you multiply it out, you do end up with this 4 plus 8x plus 4x squared. Notice now we have an equation with x squared. In order to solve this, we need to get it equal to 0. And remember what we did last chapter on how to solve quadratics, an equation with an x squared. So I'm going to subtract x squared from both sides and subtract 900 to get the left side to be equal to 0. And then on the right side, and I just rearranged the terms so that it's written in the order that we're used to seeing it, with the x squared term first and the number last. So I end up with this 3x squared plus 8x minus 896. And thinking back to what we learned last chapter about how to solve this, we have two options. We could either factor or use the quadratic formula. And it's entirely up to you where you go from here. Personally, I would rather use the quadratic formula because of the really large number, 896, okay? So I'm going to use the quadratic formula, and there's the formula, just a refresher. So my A is 3, my B is 8, my C is negative 896, and I plug the numbers into the formula and multiply it out. That gives me, and the nice thing is underneath the square root symbol, it's 10,816, and the square root of that is 104. So it's nice I have a nice square number underneath the square root symbol. Okay, and it gives me 104. So that's how I get my two answers. I take negative 8 plus 104 divided by 6, which is 96 over 6, which is 16. And then on this side, I did negative 8 minus 104 over 6, which gives me negative 112 over 6, which is negative 56 over 3. Now, remember what we're doing here. X is the height of the tree, and when we find x, that's our answer for the height of the tree. So the negative answer does not make sense at all in this situation because X is the height of the tree. So all I have for my answer is 16, so the tree is 16 feet tall. Sounds reasonable. That's the other thing you need to think of, okay? The negative answer is not reasonable. To say a height of a tree is 16 feet is a reasonable amount. If you end up with something like 0.00005 feet, not so reasonable. Or, you know, if you end up with something like 10 million, that's not a reasonable answer. So in a word problem, make sure your answer makes sense. Do things like eliminate the negative one for the height of the tree. Just think about the practical side of the situation for that, okay? And I'm going to pause for just a second, look in the chat box, and I don't see any questions. So, okay. Now I'd like to move on to do some perimeter and area type questions. Let's look at this one where it says, a ceiling measuring 9 feet by 15 feet can be painted for $60. How much would it cost to paint a ceiling 18 feet by 30 feet? Well, it's tempting to look at this and say, well, the 9 is doubled to 18, and the 15 is doubled to 30, so why don't we just double 60 and say $120? But 120 is not the right answer. And here's why. The larger ceiling has twice the length of the smaller ceiling and twice the width of the smaller ceiling. So remember the area, you're taking length times width to get the area, taking length times width. If you have 2 times the length and 2 times the width, you have to multiply the 2's together, and that gives you the area of 4 times the area, because you have to multiply the 2's together as well. So what's happening is that the area is multiplied by 4 because the area is doubling in length and doubling in width. 2 dimensions are being doubled, so the area is being multiplied by 4. So to solve this problem, you need to take the $60 times 4 and get $240. Let's say that the dimensions were tripled, and so instead of 18 and 30, we had 27 by 45. So that means the length is times 3 and the width is times 3, so the area would be times 9. And if you were going to triple each side, then you would have to take the area, which is $60 for the area, times 9. So, because $60 deals with area, it's the area to be painted. And I know it's not actually finding the area, but it deals with the area, because when you're painting, you're covering a surface. So the $60 is related to the area, and if the dimensions are tripled, where the length is tripled and the width is tripled, then the area is actually being multiplied by 9 because it's 3 on each side. So just kind of warn you about that. There's a couple homework problems where it's easy to get this marked wrong because you think, oh, times 2, times 2, times 2. And you have to think about the area when it comes to the cost of painting. Okay, let's take a look at another problem, the area and distance around the blue figure here. The figure is a rectangle with 2 semicircles. So you have a semicircle here and a semicircle here, and then on the inside it's a rectangle. So that's the situation. The perimeter of this blue figure would be the length of the 10 feet and the 10 feet. So you add those 10s together. But then you also have to take into account the curved pieces. And since they're semicircles, the curved pieces, when you put them together, it makes a circle with diameter 8 feet. So we're going to use this fact to find the perimeter. So the perimeter, I'm going to add the 10s together. but then I also need to find the distance around that circle, which would be the two semicircles added together. Okay, so I'm going to use the circumference formula, which is pi times diameter. So I'm going to take 8 times 3.14 to get the circumference of 25 feet. Now I want to mention something about the 3.14 real quick. In my math lab, if the directions tell you to use 3.14 for pi and you don't, instead let's say you push the pi button on your calculator, you might get the wrong answer because the pi button is not exactly 3.14. It's actually more accurate for pi because it goes past the 4. Like if you push the pi button on your calculator, you'll see numbers after the 4. So if my math lab tells you to use 3.14 for pi, you need to actually type 3.14 even if you have a pi button on your calculator. Okay, so pay close attention to the directions in my math lab for how you're going to handle pi. All right, so I type 8 times 3.14, and if the directions say like round to the nearest whole number, that gives you 25 feet for the circumference of the circle. So you have the 2 straight pieces plus the circumference of the circle gives you the perimeter all the way distance around of 45 feet. Now to find the area, we're going to look at this also as a rectangle with 2 semicircles. If we find the area of this circle, which when you put it together is one big circle, and add that to the area of the rectangle, then you have the area of the whole thing. Okay? Well, the area of the rectangle is 8 times 10 because it's an 8 by 10 rectangle. Notice when you multiply 10 feet times 8 feet, you get 80 square feet, or you might see it written like this with like FT with the little 2 up there. That's the same thing as square feet because you're multiplying feet times feet. Area always has square units because it's dealing in 2 dimensions. So you need to show that in the units, okay? So the rectangle is 80 square feet. Now we have to find the area of the circle, which is the 2 semicircles put together. Let's find the area of the circle and add that to the 80 square feet. So the diameter is 8 feet, so that means the radius is 4 feet. And I'm going to put 4 in for r, my circle formula, pi r squared. Okay, so if I have the diameter, I have to find the radius by cutting it in half. And then I put the 4 in for r and square it. Again, my feet are being squared, okay, because it's area. And there's my 3.14 for pi. When you take 3.14 times 4 and round to the nearest whole number, that's 50. So here I have the rectangle piece plus the 2 semicircles gives me the total area of 130 square feet. Okay. So when you see pictures like that, it's a good idea to break it up into pieces. Like if there's, you know, something like a rectangle and a semicircle, something like that, break it up into pieces and deal with the pieces separately. Okay. Last topic for this webinar has to do with similar triangles. Now, similar triangles are 2 triangles where the corresponding angles are the same measure and the corresponding sides are proportional. And what I mean by that is basically it's a copy of the triangle, but it might be enlarged or a little smaller. So remember that no matter the size of the triangle, all 3 angles have to add up to 180 degrees. So you can make a triangle really, really big, and the angles are going to stay the same. It's the sides that change. And if you notice in this picture, angles B and E are the same because I have them marked the same. That shows you which ones are the same. And then A and B are the same, and C and F are the same. And so basically what I've done is taken triangle ABC and I blew it up and made it bigger, and that gives me triangle DEF. Okay, and so there's similar triangles because it's the same, all the corresponding angles are the same, but it's just a little bit larger. DEF is a little larger. Now, when I say that corresponding sides are proportional, that means you can write, proportion is where ratios are equal. So that means you can write out an equation like this. And what I did with the corresponding sides, okay, what I did is I wrote my ratios as small triangle to large triangle. And so 10 and 20 those are corresponding sides because when I blew the triangle up, the 10 turned into a 20. And there's the 10 and the 20 right there. The next one, 6 and 12, those are corresponding. When I took the smaller triangle and blew it up, the 6 turned into a 12. There's the 6 and 12. And then the last pair of sides, I have the 7 and the 14. 7 and 14. Now notice that the whole way across for all of these ratios, I have the small triangle on top and the large triangle on the bottom. You could write it the other way and do the large triangle on top and the small triangle on the bottom. That's not a problem. The key is that you have to be consistent with it. You can't just do some ratios one way and other ratios the other way in the problem. However you're going to work the problem, whichever way you're going to do that, you just decide at the beginning of the problem and work the whole problem that way. So for this one, I decided I'm going to do small over large for all of my ratios, okay? I could have done large over small, and then all of the ratios would just be flipped over. But you have to be consistent the whole way across for all of the ratios. Whichever way you decide to do it, you work the whole problem that way. Because if you mix them up and put some where the larger number's on the top and other ones where the larger number's on the bottom, you're going to get all kinds of wrong answers, okay? That's a real common mistake with these similar triangles. You want to be consistent with how you're writing your ratios. Okay, so let's look at one where we need to do some solving. So that's an example of how to set things up. Here's one where we need to find x and y, and how you can tell which ones are corresponding is how I have them marked. These angles are marked the same, so those would be the same measure. And these angles are marked with the little squiggly thing. Those are the same, so those are the same measure. And then the other third angle has no markings, so those are the same. So basically it looks like I took the larger triangle and shrunk it down a little bit, and that gives me the smaller triangle. So I thought, well, with this ratio, I'll do large over small. So 12 corresponds with 6, like that. And then I have 13 corresponding with y, so there's my 13 over y. And then I have 5 corresponding with x, there's my 5 over x. But notice for all of those ratios I used the same pattern of large triangle over small triangle. We can use this to solve. Now, I know you may be able to look at this and tell the answers for x and y, but that's not always going to be the case. So I'd like to show you how to actually solve these equations, assuming that you can't just look at it and tell. Okay, some of them you can, but let's pretend you can't. Now, when you solve it, we are going to need to use this 12 over 6 because that's things we know, and we could just like pick out this piece here and solve that for x. So that's what we're going to do next. I have 12 over 6 equals 5 over x. And just like I mentioned before, when you're solving equations with fractions in them, multiply by the least common denominator. And between 6x, the least common denominator is 6x. So I multiplied the left side by 6x, and I multiplied the right side by 6x. And when you cross out, the x is crossed out here, the 6 is crossed out here. My left side now has 12x, and my right side has 5 times 6. So this is gone, this is gone. Anytime you multiply by the least common denominator, it's going to eliminate the fractions. That's the point of multiplying by the least common denominator. Okay, so now I see I have 12x equals 5 times 6, and so 12x is 30. Divide by 12 to get 2.5. So that tells me the length of that side that's labeled x is 2.5. So I have that now. I can go back to what I wrote and find an equation to find y. I can still use my 12 over 6 and still use my 12 over 6, but instead of setting it equal to 5 over x, I'm going to set it equal to 13 over y. So we're just going to use those two pieces and write an equation to solve. Okay, so I come over to here, and now the least common denominator is 6y. So I multiply by 6y on both sides. And what that does is allows me then to get rid of the fractions. And I have 12y on the left and 13 times 6 on the right. And when I divide both sides by 12, I get 6.5. So using this equation to start off with, this right here, that is your key to finding the pieces that you don't know with the similar triangles. Making sure you're consistent with how you're writing the large and the small the whole way across, and then once you have this written down, you can take out pieces of it to go ahead and write equations to find the pieces that you don't know. So we can use similar triangles to find sides of a triangle that we don't know. Okay, what I'm going to do is check again in the chat box and see if there are any questions, and I don't see anything. Okay. So in this webinar, we discussed angles and how to find angle measures and the Pythagorean theorem. We also looked at perimeter and area and similar triangles. So it's a lot of different topics in geometry, and I really hope it's been helpful. I do have a disclaimer on all my webinars. I don't know why, but I just want to emphasize that you still need to do the reading, watch the videos. This is meant to be a supplement to those things. So it's real important that you still take care of doing all of the assignments that you normally do for your modules. There's my email address. Email me if you have questions. If you want a copy of my slides presentation for this evening, for this webinar, just send me an email and I'll reply to you with my PDF file that has all these slides in it. So if you want to do that, you can just email me that, just asking for the webinar on geometry, and I'll reply with that file. I'm really good at answering pretty quick. So I just want to thank you again for taking the time to take part in this webinar on geometry. I hope it's been helpful. And again, if you have any questions, just go ahead and send me an email. And thank you again for coming to the webinar. Have a good evening. Bye-bye.